techniques here. This is actually section 5.6. Call it zeros of polynomials. So skill-wise, still using synthetic division, still using some factoring, but if they give us no information about the zeros of the polynomial, they don't give us a factor, they don't give us one of the zeros, what do we do then? What we do then is we make a list of the possible rational zeros. And we call it P over Q list. The P are the factors of the constant. Q are the factors of the leading coefficient. So that coefficient in front of the highest power. Okay, so listing that, what this is coming from is what's called the rational zeros theorem. It says if you've got a rational zero, and what makes a rational number is just a number that can be written as a fraction. That's what a rational number is. If you've got a zero that is a rational number, then it will be in the list of P over Q. Doesn't matter. The list will have more numbers in it than that are zeros, but the zeros that are rational will be in that list. Okay, so what we're going to be able to do is we're going to first just list the possible rational zeros. Not even going to find any yet. We're just going to list the possible ones. That P over Q list. And every practice EOC that I've seen and question bank or released items from the past couple of years, there's a question on there that just asks you to do this. College algebra, when you get to this stuff in college algebra, every year there's on the final exam from UT Martin or Bethel or whoever we give it for, there's a question or two that just say, list all the possible rational zeros. And it is a really simple thing. Let's take a polynomial like this. F of x is equal to x cubed plus 2x squared minus 11x plus 12. When I say the P over Q list or the possible rational zeros, this number is P. What's in front of x cubed? A 1. That number is Q. So when I make that list for P over Q, I need the factors of 12. What's it mean to be a factor of 12? Yeah, things that can go into 12. Okay, so things that go into 12, 1 obviously. That's what's going to be on there every time, right? And then what else? 2, 3 goes into 12, 4 goes into 12, 6, and don't forget 12 goes into itself. We have all the factors of 12 on top. Now, since we're dealing with polynomials, we've got to also think, okay, that's plus or minus on all of those. I kind of let you get by with not writing plus or minus in front of all of them. You'll see, if you look at this in a lot of textbooks, they're going to write an individual plus or minus in front of each number. I don't require you to do that because just know the plus or minus goes in front of all of them. So just put one of them there. On the bottom, we want the factors of Q. Q is 1. It's really nice when that leading coefficient is 1 because you only have one number in the bottom, plus or minus 1. Okay. The list is positive and negative, all of these. And what you do is you divide each individual up here by each individual down here. Since there's only a 1 down here, that makes that list really easy to find. So you use 1 divided by 1, 2 divided by 1, 3 divided by 1. 4 divided by 1, 6 divided by 1, 12 divided by 1. And then you're done. Okay, so the possible rational zeros are plus or minus 1, plus or minus 2, plus or minus 3, 4, 6, and 12. We've narrowed down the possible rational zeros for this polynomial from every number in the world down to this set of 12 numbers. Why is it 12, not 6? The plus or minus, we got positive and negative each one. Okay, so we've narrowed it down to, if there's a rational zero, it's one of those 12 numbers. And then I'll show you what to do after that. But here we're just making that list. That's our goal here, is just to make that list. Once we get that list, we can do some stuff with it. Let's do the same thing for this one. Let's put a number in the front. Say we got 4x to the 4th minus x cubed 3x squared plus 9x minus 10. So on the top, we want the factors of what number? The factors of the 10, it's the constant on the end. So what are the factors of 10? 1, 5, and 10. And then on the bottom, we want the factors of 4. This 4 that's in the very front. Leading coefficient is what that's called. Okay. What are the factors of 4? 1, 2, and 4. Okay, so we've got 3 numbers on the bottom now. So when we go to make our official list, we've got to divide all of these up top by 1, then divide them all up top by 2, and then divide them all up top by 4. Okay, so our list is going to be larger this time, right? So let's make that list. And I always put it in curly braces because it's a set of possible rational zeros. And I put a plus or minus in front just to say, okay, it's positive and negative, all these numbers. I divide them all by 1. That's the easy part. 1, 2, 5, and 10. If I divide them all by 2, what's 1 divided by 2? 1/2. What's 2 divided by 2? Have I already got 1 listed? Okay, so I don't have to list it again. What's 5 divided by 2? It's 5 over 2. It doesn't reduce. 10 divided by 2. 5. I've already got 5 listed, so I don't have to list it again. Now we divide them all by 4. 1 divided by 4, 1/4. 2 divided by 4. We already got it listed? Yeah, so we don't have to do it again. Okay. 5 divided by 4. 5/4. Don't have that one listed yet, so we've got to write it down. 10 over 4. It reduces to 5 over 2, which we already have. So this is our list of possible rational zeros. Still narrows it down from every number in the world to a smaller list of possible rational zeros. Doesn't mean that all of them are rational zeros. Doesn't even mean that our polynomial has rational zeros. Just means if it does, it's in that list. Okay. Now let's take that and do a problem from scratch, and we're actually going to find all the zeros of the polynomial. F of x is equal to x cubed minus 8x squared plus 11x plus 20. Okay. Now, it's got 4 terms in it. Normally, we would try to factor that by grouping if we could. It won't factor by grouping because the first 2 have x squared in common, leaves x minus 8. The second 2 don't have anything in common, so it wouldn't match. So factoring would not work on this. That's why we need synthetic division. That's why we need this rational zeros theorem to be able to find the zeros of this polynomial. So what we want to do is make our rational zeros list, the P over Q list. so that we know what numbers that we can even try. Since there's a 1 in front of x cubed, what are the only numbers in our list? 1. The factors of what number? 20. 1, 2, 4, 5, 10, and 20. That's our P over Q list. Those numbers. Now, back when I was in high school, graphing calculators weren't as readily available. Definitely weren't as affordable as they are now, even though $100 doesn't seem like it's affordable, but it is compared to what they were back in the mid-90s. You didn't have that luxury. So what we would have to do is just guess, pick one of those numbers, and try it out. If it didn't work, try another one. If that one didn't work, try another one. And you would do that until you found one that worked. Okay? You guys have a graphing calculator readily available to you. Let's use it as a tool to speed things up a little bit so that we're not guessing. We're going to use the graph of this polynomial to help us. Okay? The graph of the polynomial, what's going to happen here is when we graph this polynomial. So I'm going to go to my graphing calculator. I'm going to go to y equals. I had a stat plot on from some other class. Turn that off. And I'm going to graph that equation. X to the third minus 8x squared plus 11x plus 20. And I'm just going to hit graph. I'm going to have to fix my window here. I had it zoomed weird. Zoom 6 to get back to the normal window. Now, when we find zeros of a polynomial, we're looking for where it's crossing the x-axis. We just need one to get us started. I see this thing crossing the x-axis in 3 spots. Okay, I just need one of them to get me started with the synthetic division. I've got a possibility here at -1, a possibility here at 1, 2, 3, 4, and 5. I think they're crossing there. I can check that by synthetic division or by using the trace function on my calculator. I'm going to use the trace function because then I don't have to do a whole lot of arithmetic. So I'm going to hit trace, and I'm going to try that +4. This one right here. I think it's crossing at +4, so I'm going to use that. So I type a 4 and hit enter. The y value for that ordered pair is 0. That means 4 is a 0 for this polynomial. Okay? So that's, instead of them giving us a 0 to the polynomial, we got to find one. Where it's crossing the x-axis helps you find one. We know, is 4 in our P over Q list? Yeah, it is. So I'm going to use that 4 in synthetic division. 1, -8, 11, 20. 1, 4, -4, -5, that's -20. What do you know? The remainder is 0. That should happen. Okay. So we know that our zeros, x equals 4 is one of them. Okay. I'm verifying that through this synthetic division. That's the verification of it. The work shown. Okay. Now, I started with x cubed. What does it make this? Every time I do synthetic division, it does what to the degree of the polynomial? Lowers it by how many? 1. So it makes it an x squared problem. So this is really x squared minus 4x minus 5, a quadratic. If I have a quadratic, I have a lot of ways to solve that. I've got factoring, quadratic formula, completing the square. Nobody ever does that one. Or can't do square roots on this one unless you complete the square. But we can solve that either by quadratic formula, or this one will actually factor. I'm going to factor it. Multiply to be -5, add to be -4. So it'd be x minus 5, x plus 1, X minus 5 equals 0, so x equals 5. X plus 1 equals 0, so x equals negative 1. So we have zeros at 4, 5, and negative 1. Look back at the graph. Where did it cross the x-axis at? Those same places, 4, 5, and negative 1. It had all three of its zeros were rational. That's not always the case, okay? You won't always have all three of them being rational. It's nice when it is, because then we can verify, did we factor it correctly? Did we get the right places? Because we know that it crosses here at negative 1, here at 4, and then there's 5. It's where it's crossing the x-axis. Okay? The verification of that, or the evidence shown, it's not just the graph, it's the work that's shown here, the synthetic division, and then either factoring or quadratic formula. I don't care which way you solve the quadratic. Both ways get the same answer. Okay? You may be better off to just do the quadratic formula every time, because you know it will work. Factoring doesn't always work with quadratics. Okay? So here we found the 3 zeros. What was the degree of the polynomial, the highest exponent? It's 3. That means we found all of them. We're done. Okay? That's what we're trying to do here. Let's look at another one. F of x, x cubed, 4x squared. So another nice one where we've got a 1 in front of the degree term. The leading coefficient is 1, so that makes the P over Q list quite a lot easier, okay, and quicker. So what are our possible rational zeros here? Missed a couple. 6 and 3 also go into 18. We'll need both of those, actually. All right. Now, the next step is to graph the polynomial. So we'll use the graphic calculator to do that. Go to y equals, clear out the other one, x raised to the third minus 4x squared minus 15x plus 18. Graph. I'm looking for at least one place where it crosses the x-axis. I see 3 places. That doesn't necessarily mean they're all 3 rational, but maybe these are. Okay? So I've got 3 options here. That looks like negative 3, that looks like positive 1, and that looks like 2, 3, 4, 5, 6. That looks like where it's crossing. Let's check one. Okay? So I'm going to check positive 1, because positive 1 is pretty easy to do synthetic division with, right? Because then you only have to multiply by 1 every time. That makes it easier. So I'm going to hit trace, type in a 1, and hit enter. If the y value is 0 there, that means it works. And that means that it is a 0 of the polynomial. Okay? Set up synthetic division with a 1 on the shelf. And then run that through with synthetic. We should have a remainder of 0. Thanks, Mr. Martin. Here we do. We've got 1, negative 3, negative 18, and a 0 remainder. That took that polynomial from an x cubed polynomial down to what? X squared. This is x squared minus 3x minus 18. We're setting it equal to 0 because we want to find the zeros of that polynomial. We could factor this, or we could do quadratic formula. Let's do quadratic formula just because we need to practice doing that. We haven't done it in a couple of days. x equals negative b, so that'd be 3 plus or minus. And then b squared is 9 minus 4 times a times c over 2 times a, and a is 1. So simplify that. 3 plus or minus the square root of 4 times 18 would be 40 and 32. 72. 72 plus 9 would be 81. What's the square root of 81? 9. So we have two answers. We have x equals 3 plus 9 divided by 2. We can work that out. And x equals 3 minus 9 divided by 2. And we're going to work that out. 3 minus 9 would be negative 6. That'd be negative 3. 3 plus 9 is 12. 6. Those are my zeros. Just so happens this one had all rational zeros. They don't always do that. It's nice when they do because I can verify that those are correct by looking at the graph and seeing where it crosses the x-axis. We already knew it crossed at 1. At negative 3, it also crosses. And at 6, it also crosses. 3 places. Okay. Because they're all rational. Doesn't necessarily mean that it's always going to be that way. Look at this polynomial. Put a number in front of the leading, as the leading coefficient. All right. 9x to the fourth plus 3x to the third minus 30x squared plus 6x plus 12. We'll have to do a little bit more work on our P over Q list this time. What goes on the top? Factors of what? 12. What are the factors of 12? Okay. What goes on the bottom? Factors of 9, which is 1, 3, and 9. So our list is going to be a little longer because we're going to have all the factors of 12. So that's dividing them all by 1. Now we can divide them all by 2. So that's 1/3, by 3. 1/3, 2/3. 3 divided by 3 is 1. We already got that listed. 4/3. 2, we've already got that listed. 12 divided by 3 is 4. We already got that listed as well. Now divide them all by 9. 1/9, 2/9. 3 over 9 reduces to be 1/3. We've already got that. 4 over 9 doesn't reduce. 6 over 9 is 2/3. 12 over 9 is 4/3. So there's my P over Q list. So we know those are the possible numbers we could try in synthetic division or with the graph and see where it's crossing at. Okay. So I want to pick something out to go on that shelf up there that's going to be good in synthetic. Try to avoid fractions if possible because that makes synthetic harder, right, with fractions in it. But you won't always be able to avoid them, but try to. So I'm going to graph that polynomial. Y equals, clear out that one, 9x to the fourth, 3x to the third, negative 30x squared, 6x, and then plus 12. And I get a little view of that polynomial. Okay. So I see it crossing right here, looks like at -2 maybe. This place right here looks like it's in between. In between the -1 and 0. It might be -1/2. We don't know for sure. Right here, looks like it goes through the x-axis and then turns around real quick and goes back through it. But it's close to 1, so I'm thinking something might be happening at 1 there. I'm not sure. But I'm pretty sure that's going straight through -2. I'm going to try that one. Trace -2. And I do get a 0 for the y. Okay. Use the one that's the most obvious, and then we're going to use something else after that. Okay, so 2 works, -2 should work in synthetic division. So run that through. 9 drops down, that's -18, -15, that's +30, so that's a 0, 0, that's a 6. And the remainder is 0. Is this a quadratic? Well, what do we start with? 4th power. We did synthetic 1 time, so it brought it down to 3rd power. It's not quadratic yet. That means I probably need to do synthetic 1 more time to get it down to quadratic. Once we get it to quadratic, it makes it much easier to solve because we have factoring, we have a quadratic formula. We don't have a cubic formula to use. You could make one. It's incredibly complicated to make it work. So it's not advantageous to do that. So let's run synthetic with one of these other numbers. So we look back at the graph. We've already used -2. And we look at that graph and we think, okay, that looks like maybe -1/2. I want to try to avoid fractions if I can. We thought this might be +1. So I'm going to trace +1, see if it works. Trace 1. We're lucky. It does work. So that means that I can use synthetic division with a +1 on this polynomial. Not the original. I'm going to use it on this one. Even though that 0 came from the original, it'll still be a 0 of this one. Okay, so I'm going to use +1 and run that through. All right, there we go. Now I've got zeros of x equals -2, x equals 1. And then now I've got this down to a quadratic. That's good news. That means I can solve this using quadratic formula, perhaps maybe even factoring. It's 9x squared minus 6x minus 6 equals 0. What can you do to make that a little bit easier? What do you know about all those numbers? They're all divisible by 3. So divide them all by 3. Make it easier on yourself. So that's 3x squared minus 2x minus 2. I don't know if that'll factor or not, so I'm just going to go straight to quadratic formula. If I'll try to factor it, I've got to go something that multiplies to be -6 and adds to be -2. Nothing jumps out at me right off the top of my head that's easy to do, even though the numbers are not big. So I'm just going to go straight to quadratic formula. X equals -b plus or minus radical b squared minus 4ac divided by 2a. Work that out. 4 plus 24, 6. So that's 2 plus or minus the square root of 28 over 6. Ugh. What's 28 breaks down, right? 7 and 4, 2 and 2. So there's a pair of 2's. So that's 2 plus or minus 2 radical 7 over 6. And that'll the 2's in the front and the 6 on the bottom. All 3 of those are divisible by 2. So I'm going to divide them all by 2. So that's 1 plus or minus square root of 7 over 3. Those are our other two zeros. That's not rational. Those are not rational zeros. Rational zeros are nice, easy, good-looking fractions or good-looking integers. Those are rational zeros. So the other two zeros, x equals 1 plus the square root of 7 over 3, x equals 1 minus the square root of 7 over 3. Those are the other two places that it happens to be crossing the x-axis. Those. So we had two rational zeros and then two that weren't rational because they still had the square root in them. That's what makes them non-rational. Process is the same, though, whether they're rational. You're going to start with the P over Q list. A rational zero should be in that list. Okay. Let's look at one more here. Finish off the day here. F of x is equal to x to the fourth minus 22x squared minus 75. P over Q. This one's easier because we only have the factors of 75. What are the factors of 75? 1, 3 goes into it, 5, 15 goes into 15 times 5 is where that comes from. 3 times 25, and then 1 times 75. I tend to think about my factors as pairs, like so I get one on one end and kind of work my way to the middle. So I have a possibility of those, just a smaller list this time. When I set up my synthetic, though, what do I have to put in there? A 0 for x cubed, a 0 for plain x. Now what do I do? Graph the polynomial. X to the fourth minus 22x squared minus 75. We're just looking for some place that it hits the x-axis. Looks like a couple of places. I don't see 4 places this time. I just see 2, but the other 2 may be off the screen, may just be out of view. But we've got a couple that we see here. That looks like -5 and +5. I'm going to try +5. So I'm going to hit trace, +5. Yes. So I'm going to run synthetic with a +5. 1, 3. What do you know? It works. Is that quadratic? The red line? What did we start with? Started with x to the fourth. We did synthetic one time. That'll reduce it down to x to the third. So that's not quadratic. I know that it looks like it's crossing at -5 as well. So I'm going to use -5 to break it down one more time so that I've got an x squared problem to work with. 1, 0. What do you know? The remainder is 0. So we get zeros at x equals 5, x equals -5, and then we've got this quadratic left over, x squared plus 3 equals 0. How do I solve that? I could do quadratic formula. B is 0 in this case. Or I could just do square roots. Subtract 3. And then take the square root of both sides, plus or minus on that side. Square root of -3, what comes out? An I. So it's plus or minus I radical 3. Positive I radical 3, negative I radical 3. We found 2 rational real zeros and then 2 complex zeros. Because I in there, that's a complex number. Here's the neat thing that's happening here with this polynomial. The graph does not cross the x-axis for complex zeros. It only crosses for real ones. Okay, so you wouldn't see these two show up. You've got to find the real ones to be able to find those. That's why we got to do synthetic until we get it down to quadratic so that we can find those complex solutions. Tomorrow's workday, page 374, 11 through 18, 24 through 35. Do all of those. Go back to working on the book a little bit tomorrow. All right. Breakfast is up here, guys. Homework from last day or so. I think we had a stack up there on the desk.